Did you know that if you lie on a bed of nails, it won't pierce your skin, but if you step on a single nail, it will? This is due to the principles of force and pressure. Imagine yourself lying comfortably on a bed of nails. Sounds impossible, right? But it's a fact that a bed of nails won't harm you. Now picture stepping on an isolated nail. Ouch! That would certainly puncture your foot. But why is that? It's all about force and pressure. Let's delve into this a bit. You see, force is essentially the push or pull that objects exert on each other. It's like a tug-of-war game. Each side is pulling with a certain force. The more force you exert, the more likely you are to win the game. Now let's think about pressure. Pressure is force distributed over a certain area. It's like the difference between stepping on a Lego brick with your bare foot and stepping on a soft rug. The Lego brick hurts because the force from your foot is concentrated on a small area, creating high pressure. The rug, on the other hand, spreads out the force, resulting in lower pressure. So back to our bed of nails. When you lie on a bed of nails, your weight, which is a force due to gravity, is spread out over the many points of the nails. Each nail supports only a tiny fraction of your weight, so the pressure on any one nail is quite small. On the contrary, when you step on a single nail, your entire weight is supported by that one point, creating a high pressure enough to pierce your skin. Intriguing, isn't it? This paradox can be explained by understanding the basic concepts of force and pressure. The world of physics is filled with such fascinating phenomena just waiting to be explored. Stay tuned as we delve deeper into the concept of force and pressure in the upcoming scenes. Force, in the simplest terms, is a push or a pull. It is the interaction that, when unopposed, will change the motion of an object. Now let's break this down a bit. Imagine you're playing a game of tug-of-war. You're pulling on the rope with all your might, but the rope doesn't move, and neither does your opponent. This is because the forces you're both exerting on the rope are equal and opposite. However, if your team pulls harder, the rope moves in your direction. That's force in action, causing movement or change. The concept of force is a fundamental aspect of our understanding of the physical world. It's the invisible hand that shapes the universe, from the smallest particles to the largest galaxies. It's what makes apples fall from trees, keeps planets in orbit, and allows us to walk, run, and jump. There are several types of forces that we encounter in our daily lives. The first is gravitational force. This is the force that the Earth exerts on us and keeps us grounded. It's the reason we don't float off into space. Next, we have frictional force. This is the force that resists the motion of one object sliding or rolling over another. It's why we can walk without slipping and why we need to pedal harder when we're biking uphill. Then there's applied force. This is the force we consciously exert on objects to move them. For instance, when you push a door to open it, you're applying force. Lastly, we have normal force. This is the force exerted by a surface that supports the weight of an object resting on it. It acts perpendicular to the surface. For example, the chair you're sitting on right now is exerting normal force to counteract your weight and keep you from falling through. So, force is essentially what causes an object to undergo changes in speed, direction, or even in shape. And understanding this allows us to make sense of the world around us, from the comfort of our homes to the farthest reaches of the universe. Now let's unravel the concept of pressure. It is the force applied perpendicular to the surface of an object per unit area. Imagine your hand as a surface and a book as a force. When you place a book on your hand, you feel a certain amount of weight, right? Now, what happens when you stack more books on top of the first one? The weight increases. This is because the force, in this case the weight of the books, is distributed over the same area, your hand. So in essence, pressure is a measure of how much force is applied over a specific area. The more force you apply on a smaller area, the more pressure you create. Conversely, the same force spread over a larger area results in lesser pressure. Now let's talk about the relationship between force and pressure. It's a simple mathematical relationship, really. Pressure equals force divided by the area over which it is spread. This means that if you increase the force while keeping the area constant, the pressure increases. Conversely, if you increase the area while keeping the force constant, the pressure decreases. To give you another example, think about a thumbtack. The pointy end of the thumbtack has a very small surface area. When you push the thumbtack into a corkboard, you're applying a certain amount of force over a small area, which creates a high pressure, enough to penetrate the board. On the other hand, if you try to push the flat end of the thumbtack into the board, it's unlikely to go through. This is because the same amount of force is now spread over a larger area, resulting in lesser pressure. It's interesting to see how such a simple concept plays a crucial role in our everyday life. From the shoes we wear to the tools we use, and even in nature, like how a sharp knife cuts more effectively than a blunt one. So pressure is all about how much force you're spreading over a certain area. Force and pressure are not just scientific terms, they are part of our everyday lives. Let's dive right into our daily routines and uncover the hidden force and pressure at work. Picture yourself pressing the snooze button on your alarm clock. It's an action most of us are guilty of, but have you ever stopped to think about what's really going on? When you press the button, you apply a force over a certain area and voila, you've got pressure. Now think about your morning walk or jog. Each step you take is a dance of force and pressure. When your foot hits the pavement, the force exerted is spread over the area of the sole of your shoe. This is pressure at work, folks, allowing you to walk without sinking into the ground. And how about writing with a pen? The force you apply on the pen is transferred onto the paper through the pen's tip, creating pressure that leaves an ink mark. This is why you can't write effectively with a pen if you don't apply enough force. But it's not all about the physical actions. Understanding force and pressure can make many aspects of life easier. For instance, knowing the amount of force required to open a jammed door or the amount of pressure needed to pump air into a bicycle tire can save you from unnecessary struggles. Beyond practical applications, this knowledge can also spark curiosity and foster a deeper appreciation for the world around us. It can make us wonder about the forces and pressures at work in nature, like the force of the wind that blows leaves off trees, or the pressure exerted by the weight of the water in the ocean depths. In essence, force and pressure are at the heart of our interactions with the world. They are in the breeze that blows our hair, the rain that patters on our roofs, and even in the words we write and the steps we take. So, you see, the principles of force and pressure are deeply rooted in our daily lives. Let's recap the key points we've discussed today. Our journey started by understanding the surprising power of two fundamental concepts: force and pressure. We discovered that force is a push or pull on an object, resulting from the object's interaction with another object. This interaction can move an object, stop it, or cause it to change direction. We also learned that the unit for measuring force is the Newton, named after the great scientist Sir Isaac Newton. Then, we delved into the concept of pressure. We found out that pressure is the amount of force applied per unit area. It's like the difference between stepping on a single sharp nail and laying on a bed of nails. When force is spread out over a larger area, it lessens the pressure, which is why lying on a bed of nails doesn't hurt as much as stepping on a single one. Our exploration didn't stop there. We then moved on to investigate how force and pressure are intertwined in our daily lives. We discussed how the force exerted by the wind can push a sailboat forward, how the pressure in car tires affects the vehicle's performance, and how the force exerted by our feet allows us to walk or run. We also touched on how pressure enables us to do simple things like drinking water through a straw or writing with a pen. It's the pressure difference that makes the water rise in the straw and the force exerted by the pen on the paper that makes the ink flow and allows us to write. Understanding force and pressure not only helps us comprehend complex scientific phenomena, but also the simple things that we do every day. So, the next time you step on a single nail or lie on a bed of them, you'll know why it hurts or doesn't.